Hi, I'm Maya. I've become really passionate about learning how carbon dioxide pollution affects marine life. This year, my project is called Shell Defense. Can the growth of seaweed beds prevent shell dissolution caused by ocean acidification? Is seaweed the solution to shell dissolution? Carbon dioxide is a major air pollutant caused by the burning of fossil fuels. 1/4 of CO2 pollution dissolves in the ocean and creates acidic water. Acidic water dissolves the shells of marine creatures. These animals are crucial to the ecosystem and food web. Seaweed takes the CO2 out of the ocean and uses it for photosynthesis. If more seaweed can be grown in the ocean, the water can become less acidic and possibly prevent shell dissolution. What is the effect of seaweed bed growth on the dissolution of shells caused by ocean acidification? I hypothesize that if seaweed is present in a marine environment, then the seaweed will prevent shell dissolution because it will absorb the carbon dioxide that causes shells to dissolve. I set up two groups of shells. I put seaweed in one group and left the other group as a control. I made the water acidic using CO2 tablets. The ocean's pH is 8.1 and will continue to lower as more pollutants dissolve into the water. In my experiment, the pH was in the range of 7 to 8 to represent an acidic ocean. I used 3 empty bivalve shells for each group. I weighed the shells every 3 days and controlled variables like temperature, pH, light, and salinity. I tracked how much the shells dissolved using weight in grams. I also observed them under a microscope. Each group of shells started at a different weight, so to compare them more accurately, I used percent of change. In all 3 trials, the control group shells lost more percentage of weight than the seaweed group. This bar graph demonstrates the difference in percentage of weight loss between the control and the seaweed groups. The control group is represented by blue and the seaweed is in green. I calculated the mean, standard deviation, and median of percent change for all 3 trials. On average, the seaweed groups lost 0.55% and the control groups lost 1.3% in weight. I also ran a t-test. The p-value was less than 5%. This suggests that the results were significant and less likely due to chance. The results were also supported by my observations. These 2 pictures are of the same shell in a control group taken before and after the experiment. The shell seems to have lost color and some material. I observed this control group shell under a microscope before and after the experiment. The texture of the shell is rough and chalky after being exposed to carbon dioxide. Overall, the seaweed groups lost less than half the weight of the control groups. This suggests that there is a correlation between the presence of seaweed and less dissolution. The idea that ocean acidification can be managed by increasing the amount of seaweed in the ocean is promising. If people could plant more seaweed beds in the ocean, then shell dissolution may be prevented. Time was the biggest limitation in this experiment. I would have loved to extend the time the shells were exposed to carbon dioxide and observe even more shell dissolution. In the future, I would like to experiment with different amounts of seaweed. I would like to discover how much seaweed is required to prevent shells from dissolving altogether.